Okay, so here we're asked to factor a trinomial whose leading coefficient is 1. And there are a couple ways you can do this, and I'll demonstrate them both, and then of course you can pick whichever technique you're most comfortable with. I guess one way to go at it is just pretty directly, given the fact that you know that a trinomial situation like this comes out of the product of a couple binomials via FOIL. So, we can set ourselves up for that right away. So here's the receptacles for the couple of binomials that we'll eventually have here. And one thing you know about FOIL is that the first product is represented right here, the product of the first two things from the binomial. So that first product is x squared. Well, the only meaningful way for us to get that with the integer-based factoring techniques that we do is as x times x. So there's the first part of your factorization right there. The only meaningful way with our techniques to get x squared out of FOIL is x times x. So now you want to finish it off by focusing pretty explicitly on the constant term here, which is a 15. To finish things off, you're looking for a couple things to happen. You want to find some factors of 15 that will go in the last position of each binomial, but factors of 15 that you pick carefully enough so that they combine to the middle coefficient on the x here. Because when you think about FOIL, the outer and inner products are going to generate this minus 8x term, and therefore you need to pick out factors of this constant 15 so that when you place them here and do the outer and inner product multiplication with the FOIL, when you put your like terms together, you get exactly that minus 8x. So in this particular case now, you're looking for factors of 15 that'll combine to minus 8. Well, when you go through and think of factors of 15, one pair that probably comes to mind is 3 and 5. And when you think of it, if you make them both negative, minus 3 and minus 5 will multiply to 15, and they combine, minus 3 and minus 5, to minus 8. So there's one way of getting your factorization just kind of directly, just noting how things work by FOIL and noting what factors of the constant term combine to the coefficient of the middle term. So there's one way of doing it directly. Another way you could do this is you could run it by a treatment of grouping, which essentially this is, because again, kind of focusing on that constant 15 here, you could think of this as, well, there's that x squared that we led things off with, and here's that plus 15 at the end. Now you got this minus 8x in the middle. Now, the one thing again that you know is that that comes from the combination of the like terms that are generated from the outer and inner products of the FOIL. So again, still just focusing on this plus 15, since that's the only term that really has anything to do with the generation of the coefficient on the x in the middle, is again, you ask that basic same question. What are the factors of plus 15 that combine to minus 8? Well, again, they're minus 3 and minus 5. So in either order, you can kind of reconstruct the outer and inner products that generated this minus 8x from the FOIL by writing that decomposition out here. So the factors of 15 that combine to minus 8 are minus 3 and minus 5. So in any order, replace that minus 8x with, say, minus 3x and minus 5x. And now you can see by doing that, you've taken your trinomial that had only 3 terms and you couldn't run a grouping style factorization on, but by decomposing that minus 8x in the middle into basically the outer and inner products that generated it from the FOIL, now you've created a 4-term polynomial that you can use grouping on. So you group your first half separately from your last half, and you can see what little greatest common factorizations you get out of each group. From the first group, you can take out an x. That leaves behind an x minus 3. And then from the second group, the leading coefficient of the second group is negative, so you know a minus is going to come out. And then the greatest common factor you can get out of the remaining 5x and 15 is a 5, and that leaves behind a leftover x minus 3. So again, there's the signal for a successful grouping. We've got exactly the same leftover binomial factor remaining in each of these two terms. So finish it off. Factor out that common x minus 3. That leaves behind a leftover x minus 5. And there it is. Once again, there's exactly the same answer we ended up with before by the direct approach technique. So either of these are perfectly valid. When the leading coefficient's 1, just ask yourself, what are the factors of the constant coefficient that will combine to the coefficient on the x in the middle? Once you answer that question, you can either write things out directly like we did at the beginning, or you can finish things using a factoring by grouping technique.